Okie doke. It's time for coding today. Gotta do some other shit in a little while. So no game day tonight. Won't have time. I think in... Yeah, I fucked around too long. I only have 3 hours and 27 minutes till bed. Really more than that. So really, it's really 3 hours. I need to go to bed at 11:30. So we'll do C++ for 2 hours, and then I have to go find some stuff. All right, sitting good. Cool. All right. Where are we at? Inline keyword. All right, so last time we talked about inline expansion, which is something the compiler does. We haven't looked at the keyword yet, but it's where the compiler will take something like, it seems like it has a chance to do it. It'll basically find short functions that are called repeatedly, where the cost of overhead might exceed or approximate the cost of the function itself. So the cost of taking arguments, copying the values, passing them and copying them into, or well, first giving the arguments in a function, or giving the parameters in a function memory, then copying those values into them, or rather, I guess, copying the values and storing them somewhere, instantiating these variables, these parameters, by giving them spaces in memory, putting those values into them, and then running the calculations, and then returning by copying those values back. It's the copying, the passing, the instantiating, and then the copying back. It's at least like four places where overhead could happen. So we could have like, what would be a good one? What about like levels? One that's called often for a certain thing, but not called like literally all the time. I'm trying to think of it in the context of a game. Like, oh, so I can have, I'm just going to do pseudocode, but we'll say we have a function here and it's called, it doesn't return anything and it's a void, and it is, so the returning isn't the overhead, but the passing is. So it's called spawn goblin, or we could say spawn enemy at location. Excuse me, and it takes a type, so we'll just call it enemy is the type, enemy, and then enemy, or enemy name, and then let's see, or we could say maybe it takes multiple types, but we'll say first it's just enemy. It's fine. Enemy is a type, and enemy name is the name of whatever the enemy is. So it could be like enemy, so there could be goblin, and that's the name of enemy, and it has this big list of enemies, possible enemies from the enemy type, and there are different options in there maybe, and it'll check for the name and do some stuff. So we could say enemy name, and it also needs a location. So I don't know if this is like a standard vector or whatever, but we'll just say, for now we'll just say int x, int y, int z. And those are that's the location when we take them. So we have the X, the Y, and the Z axis point. And what it would do is, it would take this location. So what it would do is, there would be some kind of logic that is like create enemy. And it would call, like, let's see. This isn't a great example, because you may as well just do create enemy, and then, no, this isn't a good example. It needs to be one where the actual calculation itself, or the statements within the function. What is this shit? Nah, she's good, but where the overhead is actually exceeding the cost of the function. So we'll just do, I don't want to do add or something. I'm trying to do something that's related, but not perception, because that's constantly updating where your character's looking around. So it'd be like, I mean, one example could be a jump function where we pass jump. Well, nah, because you wouldn't pass it the location. All it's doing is updating. Well, because jump's going to be a lot more intensive because you actually have to move a character in an object that's 3D rendered. That's way more intensive. Has to be. Sure. All right. So we'll just do, okay, so returning an integer is this function called add numbers, or we could just say add. I mean, I don't really like that. I'm just going to say add. Well, I guess it's redundant if we say add numbers, so we'll just call it add. Num1 int num2. And then we'll just say it returns num1 plus num2. Easy. And then all we're doing is just passing that on. Oh, well. Oops. Didn't delete those properly. Cool. All we're doing is getting a sum here. But, so instead of passing this shit here, instead we just expand this. So we just say, this is assigned to be argument plus argument. Oh, so it's just 3 plus 4. It's just expanding what's going on in here. I think that's what it ends up looking like. So like one of these would be this function, and it takes these arguments. But instead, we just say, okay, we're comparing these two, and we are returning the smaller of them. Okay, so we just do the ternary operator. Like if we did int max, int1, oops, num1, int num2, yeah, whatever, num is fine. Excuse me, and then we just return if num1 is less than num2, sorry, if it's greater than num2, then we return num1, otherwise return num2. And then we'll say max 3, 4. Boom. But then we're not using it, it's fine. Yeah, so in this case, all it's doing is it's substituting the logic in here for the arguments, because we're taking 3 and 4, we're copying those values somewhere else in memory. So we're holding 3 somewhere and we're holding 4 somewhere. And then we're starting the function, and then we have 2 variables that need to be instantiated. So we take 2 little empty buckets in memory, and what we do is we copy 3's value, and we take it here, and we copy 4's value, and we push it in here, okay? And then we have these, and we run a calculation where we do the ternary operator, and we get a result. And then we take the value of that result, and then we copy it over back into this variable. So we've done copy, copy, instantiate, pass by value. So copy, instantiate. Well, yeah, instantiate, and then assign values via copy assignment, and then do the logic. So that's all overhead, and then returning, which is copy and pass here. So there's 2 copies, 2 instantiations, 2 value passes, another copy, another value pass. Holy shit. Instead of just running the logic that's inside. So it makes a lot more sense when you have a really simple function like that. I'm trying to think if there's another one. Like if I had a function that void function. We'll just call it like edit. We'll just say void edit name. No, it returns probably a standard string edit name, and the parameters would be string, and really it should be a string view, but we'll just pretend we're just gonna say string name and then string change, and then there would be some pseudocode here for whatever. Return excuse me, we'll just do name plus string change. Append the string. So make the name, make the edit, or perform the edit, and then we're returning it here where we're calling whatever. We have some standard string name, and we'll just call it player name, whatever, and it's by default Ethan. And then afterwards we say, okay, player name is now edit name Ethan, and then we're also passing it and we'll just say that this is appending. This is standard, like we'll just say it's concatenate name, and all it would do is add this to the end. So I'd be Ethan, perform the concatenation, boom, cool. Or string, oh, and this is a bad name too, string edit, something like that, or just edit, I don't know, something like that, edit, cool. So we're assigning the value of this function, which is Ethan plus whatever we're gonna change it. Oh, we could just do, oh yeah. So we're just assigning it this value of here. Okay, cool. Yeah. Oh, and this could just be player name. That's what that should be. So the name is passing the name with the change we're making, and we could also have string chain or name edit, and I'll just call it whatever. Boom, name edit, boom. And then this function will return that. And what would we be doing? We're copying this big ass string value. We're copying another big ass string value. We're instantiating. We're passing this copied value from here to here, another one from here to here, meaning like somewhere in memory to here, somewhere in memory to here, wherever we stored those temporary copies. And then I guess we kill them off. And then we do some shit in here, maybe. And then finally, once, or we just do this straight away. I mean, that's the point, I guess, here. That the processing is smaller. And then all this is some sort of concatenation. Maybe this is a function, so maybe this calls whatever, calls concatenate, blah, 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 whatever. And we pass in, or really it would probably be name and edit. So that function would concatenate, whatever. But whenever we call this, we may as well just call the concatenate function. We don't want to actually do, well, this is already it. But so assuming this is a thing, I can just do name and add edit to it, and it does the concatenation. Then we've copied, instantiated, meaning gave a little spot in memory, assigned a little bucket, put his name on the side, boom, because he's an identifier. If it was just this, then you wouldn't have a name, wouldn't be able to get it, I don't think, unless I store where it's created, but not what it's called. That could be kind of cool. Like unnamed, oh, maybe that's like unnamed namespaces, maybe. So maybe in an unnamed namespace, we have addresses stored. Ignorant about that stuff now. I haven't been fully trained yet. So, yeah, in this case, we're copying somewhere into memory, and then instantiating, opening little spots in memory, and then pushing those values in, and then doing this addition, and then copying this return value. So, I mean, the precedence of the addition operator comes before. Well, actually, return isn't even an operator, so it's fine. This has to happen before, so we actually don't need these. So this addition would happen, or this concatenation, I guess, would happen here, and then we are returning, boom, the whole thing. Meaning we're copying this value. We're taking this and we're not taking the standard string and putting it here. We're copying its value and then putting it here for this guy. So, oh hell no. So that is expansion, inline expansion. Nope, hold on. Specifically, we would have that standard string here, name, and then what's happening is name, string name change, and then name, whatever is, name change, name change, or concatenate name. This should, I should be better with my caps. Cool, okay. But instead of it going up here into this function and doing all this stuff, instead what should be happening is it's just replacing it and it's saying name plus name change. Boom, inline expansion. It takes all the shit that's up here and boom, just does this. That way there's no passing. It's literally using the variable, assigning the value. Boom, not a single copy except one copy assignment here. So it's really like taking the function, removing the copying of my arguments, removing the initializing or the instantiation of the parameters, and that's it. Only return in the value. That's it. We do the calculation, we return the value. So we basically just remove all the shit that happens beforehand. We still have to return the value, okay. We still have to do the logic, okay. But we don't have to prepare. We don't have to do copy, instantiate, pass. None of that. It's 6 steps gone. Don't have to do it all. Especially if we're changing names all the time. Like, especially if that function was if I subtract or I press backspace and it reduces something by the name, maybe it concatenates my name and then does like some reverse concatenation where instead of adding something to the end, it replaces the last with whatever the selection is. So we replace the last character with a space. So, boom. It goes from being N at the end for my name, and then boom, now it's blank space, ETHA, and then that's my name, and then whatever. But then I type, and it adds stuff back. So we might be doing this stuff all the time, and every time we do it, we're copying the values, instantiating, passing. Oh, there's no way. There's no way. Cool. So it allows us to optimize, do a bunch of cool shit. Functions can either be expanded or can't be expanded. Meaning functions whose logic can be pulled out and put in the line, or they can't. So most can. Compiler will check whether it would benefit. Compiler may or may not. Excuse me. It may not even do it for all calls. It might depend on the context of the call. Oh, man, I got a fucking headache or something today. I need to just pound this water. Wait, what? I haven't even been on this that long. I said, oh, 11:30. Okay, so we've been at 25 minutes. I'm like, figure I'm going to bed at 11:30. I might have to even reduce it and just go to bed at 11 because I'm fucking tired today. Just from the headache. We'll see though. Cool. So it may or may not. All right. The inline keyword. Haven't seen this yet. So maybe it biases the compiler to be more likely to do it or to try to do it. A hint, probably benefit. Okay. Meaning that we would check to see if it would benefit from being expanded. And then we would note that and we would inform the compiler that it would be. Function declared using the inline keyword. Inline static const inline extern static oh, you wouldn't do static extern. Never mind. Inline static const. Inline extern const. Well, you wouldn't need to do inline extern. Yeah, extern const. Yeah. You wouldn't need to do static const. So you either do extern const or you just do static. So inline extern. Boom. Well, no, yeah, you do extern const. Or you would just do inline static. You wouldn't do inline static const. Or, well, yeah, you would just do inline const. So it's either 2 or 3. All right. Meaning 2 or 3 qualifiers. Just trying to think of when you would use stuff. You do extern and const. Or you do const. You don't need to do static for const. Nor do you want to do static extern just to like nullify the extern. That makes no sense. Because if it's const, then it's already local linkage. Oh. Oh, let me study something real fast. Oh god, here it is. Oh, that's fucking easy. Hello? Oh, but they're doing it the easy way though. Is it actually? That's so cake. Are you kidding me? One more. That's it? That's all he's doing? Bro, this dude's tripping. Boom. Fuck, other video's not done yet. Okay, cool. Alright, back to music. Inline function. Okay. Let me wash my cup really quick. Okay. Ay. Excuse me. Excuse me again. Yeah, because all that's happening here is we're passing two arguments. Copying, initializing, passing. Okay, now we have values in these guys. And then all we're doing is returning which one is less. That's it. Which means that all we're doing is the ternary operator and passing. Well, the passing is already, well, passing isn't going to happen here. Well, passing won't happen because this is a variable that's already given this value. And it's initialized with it instead of copy sign. So maybe this part is more efficient than the passing here. Yeah, 100%. This looks like we should just absolutely make this guy inline. And then we're outputting that. However, in modern C++, inline is no longer used to reflect it. Premature optimization, meaning something that the compiler might already do, and if it determines, if assuming the compiler is pretty good at figuring out if something is worth doing, because there's probably a hit to put inline here because it's one more thing the compiler has to process. Maybe there's like some sort of optimization process it has to prep in order to actually do the expansion itself. I mean, there's got to be some cost of doing the expansion. Compared to just manually expanding this out, there's got to be a cost for the compiler to take this and explicitly expand it. So, if I do that, and it turns out that the expansion is actually less performant and less optimal than just running the code as is, or it's negligible, one, wasting the dev's time, and two, also wasting the compiler, wasting energy, wasting power, compute, wasting, yeah, it's just a waste. Yeah, which could actually harm performance, because I'm not sure what cases are best to use. So like maybe some operators, like maybe the ternary operator is actually really expensive, and it would result in a negligible performance impact. I have no clue. I'm just some fucking retard, dude. I have no idea. And I'll know at some point, but I don't know now. Premature. It's just a hint. It's completely free to ignore. Yeah, so if I put it in there and I've used my time, the compiler then had to check to say, hey, yo, that boy marked this as inline. Let's check for sure. And maybe he was going to check anyway, but now it has to do like an extra check or something, and now it's just ignoring it even though I did it. It's just a waste. Only do it when you need to. It's like giving some, like, don't ask for permission, bro. Ask for forgiveness, not for permission. Do some shit, just do it. And if you need to fucking fix it later, fix it later. Don't ask first, because then you prevent it. So if you put inline in there first, you're fucking yourself over from the get-go, instead of figuring out later, asking your boss for forgiveness and being like, okay, let me add inline now, because now it's needed. Instead of making the performance metrics be worse from the get-go. Right? Just to help. Completely free to ignore it. Also free to do it without inline. It's defined at the wrong level of granularity. The definition. Determined per call. Yeah, it makes sense. Yeah, because if you put inline and then it does an extra check every single time, well, maybe that leads it to expand it 2 times. Or maybe it leads it to expand it every time, but on some of those times, it was actually less performant to expand it. If it's already determined on a call by call base, it's totally a waste. Yeah. Yeah. Yeah, if inline said, if inline was but the whole point of using that would be for things that are called regularly. So if you did inline and it ended up being less performant using inline because it had to check to see if it even should expand it, which it's already going to do, but it might do extra because now it has the inline keyword, then if it ended up not needing it, then you're fucking it over even more. Already typically good and better than most humans. Oh, good. Likely ignore. Oh, nice. Do not use it. Modernly. Yep. Oh, wait. Do not implement them. Yeah. Don't implement the definitions in multiple header files. I mean, yeah, you could do just the header files definition and then include it somewhere. And then you have the definition itself, so you don't even need a forward declaration. It's just fucking defined. But when you have that header included into another, and then another file, those are 2 separate files that will be linked. In the linker especially, we'll see, hey buddy, we got a multi-definition here, bucko. Dude! Man, I'm good. The compiler's happy because it sees one file. The compiler only sees one file at a time. It checks, Are we good? Are we good? Are we good? Are we good? Oh, forward declaration. Oh, okay, we're good. It doesn't go and check to see if the function actually exists. It's the linker that does that and tries to piece everything together and then realizes, oh shit, yo. You said that it looks like, oh, okay, compiler says, cool, looks good, looks good. But, let's see. It's like, oh yeah, we got a whole finger here. We got the forward declaration. We're good. Surely there's a definition, right? And then the linker goes and looks for that other finger, but instead of finding a whole finger, it finds fucking nothing, yo. So this guy was happy. The compiler was cool, but the linker was not. Bro, you have fucking 4 fingers. I still think I would totally rather have my ring finger than my pinky finger. I feel like I never use my pinky finger for anything. Like this, that's what I need. Like this, that. I have so much of a weak, my grip is significantly weaker if I do that. Like, I mean, maybe it'd be different, but it really feels like, my mom was telling me that, maybe she was talking about the foot. Like your ring toe might be worst or probably better to lose than your pinky. Because if you go on the outside of your foot, your pinky's 100% activated. But like, when is your fucking ring toe activated? Like never. Probably not true at all. Yeah, when you include it, the linker's gonna bitch, because the compiler sees definition, definition. Okay, cool, but the linker sees definition, definition. Yo, it's the same definition. That's a redefinition. Boom. You put them together, compiler's happy, compiler's happy. Linker ain't happy, bro. Because it's supposed to be like this. We're good. But instead it's this, because they're both defined. So it should be define, good to go. Define, good to go. Uh-oh, to definition. That's still really weird. I don't like that. But, well, I mean, I guess I do. It's weird that I can't control my finger. Like, I'm trying. I can do that. I can do that. But once we're already past the point of max, well, not even max contraction. Even if I just do it here, I have way more to do, but. Well, I guess I can. It's just really hard. The hardest part is expanding only the tip of the finger and not the rest. I don't think it's possible. Like, I literally can't unbend the end of my finger. Wait, that's insane. Trying to straighten it. I can't do it. I have to do that. I can do that. And then I can't straighten it unless I... Ah, that's weird. Whatever. What am I fucking doing, dude? Cool. Yeah, when you include a header into multiple files, that function definition is done. Boom, redefinition, bro. Linker throws an error. Find it more than once in a program. The term inline now means multiple definitions are allowed. So an inline is one that is allowed to be defined in multiple translation units without violating the one definition rule. Yes, that is what I've heard. Compiler needs to be able to see the full definition in each one. Oh. Hmm. Yeah, probably so it knows that it's an inline. If there's something that indicates that it's an inline, the compiler needs to see it and then see it in another file. And both of them say, like, pretend it's the inline keyword and it sees it and it's like, okay, cool, you're good to use in another one, buddy. And then over here, oh, hey, yeah, you're cool to use in another one, buddy. And then the linker sees and is cool. He's happy. So I guess the compiler wouldn't really care, but maybe it would. Yeah, because the compiler wouldn't be able to tell if something's inline. Because it doesn't look at other files. It's the linker who finds out. So it should be for like a keyword for the linker. Okay. 2 requirements. Bro, what? That's 3. Needs to be able to needs to see the full definition in each one where it's used, not where it exists. 4 declarations not enough. Only 1 definition per unit. Well, duh. Yeah, otherwise you get redefinition, yeah. Can occur after a point of use if a forward... Okay, just like a regular function. Okay. Won't be able to do inline expansion until it sees the definition. Oh, meaning so if we... So any uses between the two? Yeah. So it sees it, and it's like, okay, cool. And then I'll use it, and then it'll go and find it to use it. Just like it would regularly. It sees the forward declaration, and then the linker has linked it somehow. I don't really know how, but now there's a chain between what all the calls and the definition, so they can go and use that logic. But if we haven't defined it yet, then the shit earlier can't. It's not going to go and fill in the fucking inline expansion in the past. It only happens after it sees the definition where it's saved, and then it gets substituted in there. Seems like. Okay. Every definition with external linkage must be identical. But why do we want multi-definition? What are the shortcomings here? Instead of just including 4 declarations and that, oh, because if it's something like that, we want it to be defined in another file. That way the compiler can do the inline expansion. Sure, it can do factor fold, constant folding and constant propagation, where it automatically says, oh, okay, x is 5. Okay, it just substitutes x is literally 5 now. And then anywhere x is used, it just substitutes 5. That's it. Done. At compile time. Boom. So when you run it, it doesn't even do the calculation. It doesn't even initialize x. It literally just puts 5 everywhere. That's it. Boom. 5 has been... Your logic has been changed to use the hard-coded value of 5. Sure, that can change later, but the initial values, once it's run the first time, all 5. That's it. GG, buddy. But now, we can actually expand entire function calls to get the logic that they have inside to remove the overhead of copying the values from the arguments, passing the values to variables that are initialized, your parameters. So, copying arguments, instantiating parameters, passing by value from your arguments to your parameters. So, oh hell no. Or to the, wherever the hell the temporary copies of your arguments are to your parameters. Okay. And there's some way of indicating that it's inline, seems like. It needs to be able to see the full definition, that way it can fucking do the inline expansion. And all definitions must be identical, otherwise it's undefined. Okay. Oh shit. Wait. So we can do inline now, it looks like. Oh, both have inline. Okay, hold on. So inline before. Uses the hint to tell the compiler that it's probably like that. But here it's redundant because the compiler's already going to do what you're using inline here, or inline for here. But instead, if you want to do factor inline expansion, then well, it's already it's already going to do that. But if you put it somewhere else, then you can do it in multiple different files. And the point is that if you use a function that is going to that needs to be inline expanded in multiple different files, instead of defining it somewhere and then including its forward declaration in those other 3 files, let's say you have it defined here, and then you include it in 3 files for the forward declaration, and then the linker links all those calls with the definition. That way, whenever you call it, it gets the definition. Well, what if I need to do inline expansion for each of those? Well, if I do inline expansion for one and I put, well, it might already do it, first of all. But if I want to maybe 100% do it or make it more likely, then we do inline there and inline in all the other files that it's defined in. So couldn't I do a header file and then make it inline and then expand that? Because then I'm including an inline expansion? Maybe? So mass CPP. The linker will consolidate all inline. Wait, hold on. Oh, here we go. Needs to be able to see it all. All definitions must be identical. Cool. Internal linkage and external. Yes. I know. It will consolidate all inline function definitions for an identifier into a single definition. Oh, so the linker will do it and then take that logic and then replace all the calls with it. Or wherever it should. Gotcha. So it's doing the consolidation, so it still meets ODR, one definition rule. Okay, cool. Fifth circumference, double pi, and then in the implementation file we have inline function double pi. That's a fucking weird function, but whatever. Yeah, I don't really like that logic. I don't know why you're doing it, that best practice. Just to show me that it's gross, I guess. For that weird practice. This is the function, and you just call it pi, and pi returns 3.14, 159, 162, I don't know, 138, I don't know. What's pi? 159, oh, 265, interesting. So we use pi, and we put inline, and then we put inline in the implementation file. And there's also circumference there, and that we're forward declaring it there. So, main will go and look into CPP to get circumference. Oh, and circumference is also, so that's the forward declaration of a function. Okay. We pass it a radius, and all it does is multiplies it by 2 pi. Yeah, because pi times diameter, so pi times 2r pi. Notice that both have a definition, but they're inline. It's acceptable, and it will deduplicate them. If you remove inline from both, you get an ODR. Huh. Seems like it's not. Well, yeah, I guess you would want to do that. So you can have it. Oh, I guess you could do that, huh? I guess you wouldn't need to do. Hold on. Well, if you do an inline, if you include a header file and it's inline, I feel like, wouldn't you want to define your inline functions in your header file? But maybe you want to keep it with the rest of your functions, which are not defined. They're only declared in the header file. And then the point is, but then you have to fucking manually put in the definition everywhere. It seems like including would still be better. Seems like you would define it with inline in the declaration, and it would say inline, and then you include the for declaration in the header. But doesn't it? No, but it can't be forward declared though. That's the point. In any file in which it's used, but it's not necessarily used in the header file. Though. Oh wait, it might not be. Full definition wherever it's used. Meaning, if it's used, meaning if it's included in a file. I don't know if it means called. It's not saying called, so I'm thinking used, meaning included it all in a file. So. No forward declaring inline functions. Music, wake me up. Wake up. Fans on, let's go, wake up. Wake up. Oh, that's probably why it hurts. Oh, that's why it hurt. I did 1 push-ups at work today too. Oh, oh, it hurts. I was holding my breath. I could have done so many more though, too. Probably do like 10 now. There's no way. Oh boy, here we go. They seem highly interconnected. Well, it's the same fucking keyword, bro. So before was to perform inline expansion, which now just happens anyway. Now when we use it, it allows multiple definitions. And the point of that is you allow it to do multiple definitions because the compiler is already the one that decides whether it's getting inline expanded anyway. So you include it in CPP and then you include it everywhere else verbatim. Or, well, yeah, but in the header file, if you define it in the header file too, then isn't it okay via ODR? How much further, how much more is there? Oh, there's a lot more. Good little bit. Let's fucking go, baby! That's what I thought. We define them in a header file. Yes! Let's go, dude. The logic is coming, bro. I'm not that retarded. Let's fucking go. Okay. In order to do it, must. Wait, wouldn't it not work anyway? Yeah. Hold on. In order to do it, it needs to see the full definition. Hold on. It needs translation unit, otherwise it wouldn't know. Yeah, function defined in another can't be expanded in the current one. Yeah, so it seems like before you do inline to say that you want to expand it, but at that time you couldn't necessarily do the multiple definitions, no? Yeah, makes sense. Included in both. But as soon as we do it in each definition, yeah, we violate ODR, bro. Yeah. Make inline exempt from ODR since there's only one single definition per program. Yeah. But then later it's actually okay because the linker deduplicates. I do this a lot now when I'm like figuring things out. That's so easy. Squinting my right side, the left automatically kind of goes up. I think I'm actually lifting the left more. Lifting the right is hard. Yeah. Make the inline functions exempt from ODR. That way we can have multiple definitions in a program, but then the linker goes and fixes the shit so that it's not actually multiple. There aren't actually multiple. So historically we requested it, and the ODR was an exemption that was required. Modernly we use it for the ODR exemption and let the compiler handle the rest. Yeah. So historically, we actually use it to request inline, and the ODR exemption was just a thing. But now the inline actually is the multi-definition, not the inline expansion. It might get inline expanded anyway, but so now we're just using it to do the multi-definition, whereas before it was already allowed to be multi-definition. I guess inline was the thing that was probably letting it be defined multiple times anyway. So both, that's the same. In the past, had to use inline to show that we can multiply define it. Same here. But in the past, you had to do inline to even have it be inline expanded in the first place. Now, it can already. But the point is that it can only do the inline if it sees the definition. Which maybe is why the past examples have been very seldom defining functions in other files. It's always been defining in the existing file, which potentially makes use of inline expansion because it's seen the definition before the uses, before the calls. So now we use it for the ODR exemption and let the compiler do it. Okay, yeah. Inline and non-inline. Well, it seems like it's a requirement in order to allow functions to be inline expanded. Because we probably want to do it for every file, which means that we have to use them in multiple files. With non-inline, we expect it to be defined in one place. If the linker finds multiple, it's a naming conflict. Yeah. Any call to it would lead to an... Oh, hold on. Any other call to a non-inline with multiple definitions, potential ambiguity. Yeah. But with inline, we assume that. Okay, yeah. So if I have function add, and I define them here and I define them there, the compiler says, or the linker says, yo, what the fuck is that, bro? Multi-definition? Oh, hell no. Those are wrong. You got that boy defined twice. But if we do inline, it says, nice, man, because it needs to be defined multiple times. So when it sees inline, it's probably expecting it again, or it's at least just not. It's at least letting him into the bar. It's like, oh, okay, one inline, okay. And when I see someone else with inline stamped on his head, you can come in too. But if it's normal and it says non-inline, one can come in. But if another fucking non-inline comes in here, I'm about to bust your ass up, dude, because I'm the linker bouncer. That's what I am. You call me. I don't know. I don't know what a linker bouncer's name would be. Yeah, all inline functions are assumed to be the same definition. Yeah. So the calls within that translation unit can be expanded. Yeah. Yeah, because each file needs to see it. So each one gets to be expanded with the shit that it has inside it. If a function call isn't, there's no ambiguity about which one, and you're fine. Oh, meaning it hasn't been expanded yet, and we're trying to figure out which one? Oh, it's defined here and it's defined here. Oh, it doesn't fucking matter, bro. Doesn't matter. Doesn't matter. They are defined in header files so they can be included at the top. Yes. Exactly. That's what I meant. Yeah, because otherwise you'd have to fucking manually type it in every CPP file. Oh. Oh no. Oh hell no. We have pi. We're defining it. Yeah. We're doing inline. Saying that, telling that mamma jamma what's up. Boom. We're including pi in main. Why are we including him in math? We aren't. Yes, we are. Oh, because circumference uses it. Yeah. Okay. Oh, that way we can do inline expansion in maybe, if the compiler wants to, in circumference as well. Cool. That way when circumference is called, it actually has an inline expansion inside it, which is just 3.14, 159, 265, instead of fucking calling pi. That's not even that bad. It's just returning it. I mean, it's almost the same thing. It's basically the same. Oh, header only? That way everything's in H instead of like some that are in the CPP? Yeah, exactly. Alright, let's see. Nah. Oh, so a header file that doesn't use any CPP files or functions from CPP files. It only does .h or header files. Header only libraries. No source files. Oh shit. Simply include it. Yeah, no linking issues, buddy. Holy. Meaning, because I have a file and I'm including code here. Boom. And the linker says, cool. You're good. Boom, you're good. You're good. Cool. 815. Implicitly inline. Okay. Functions defined inside a class structure union. What the fuck is a union? Functions defined inside a class are already inline. Oh, constant expression functions are inline. Oh, so I could do, really? So I could make a constant expression function in two different spots? Oh, but it's already explicitly inline. So, or implicitly inline, sorry, because I don't have to put it. It's already there by default. Oh, but I could never tell though, because I've never had two different files actually running. Function templates, what the heck? What is that? Functions and implicitly instantiated from a function template? Oh, meaning. So when I use a template and I pass it some type of variable, and then it creates a function of that type, it's like, hey, it could create any of these, and I pass it an int, and then it creates the int function that is the implicitly initialized function. So I'm not actually doing the initialization, I'm just doing a template. Do not mark them inline unless you're defining them in a header file. Okay. So it seems like okay, so we can do a header file and we'll do inline functions. If not defined, inline functions. Define inline functions. And if so do inline inline int add int num1 int num2 return num1 plus num2. Oh, and then I just include them here. Oh, so we could just do. Yeah, it doesn't work. Yeah, I thought so. We could just do standard character output, add 2 and 3. Look at that, dude. 5. But if we did that, what? It's defined here. What if we did another test file? We'll just do. So the point is, multi-definition is in CPP files. We don't care about multi-definition in header files. I mean, I guess we could. Let's see, what would happen if I just did this twice in here? It already has a body, but it doesn't actually say that it's a multi-definition. Multi-definition is when two source files, which are header files. So we need, this is a header file. The issue is that the source files, the source code, well, this is source code too, but problem is that multiple of these guys have them. But if we say inline, we're good to go. Inline allows ODR exception. One definition rule, exception. Compiler requires or must see definition. Definition in all files. We want to inline expansion in 4. Cool. Okay, sounds good to me. Alright, I think that's it. I gotta go and do my stuff. I'm also tired, so I'm probably gonna go to sleep early. Excuse me, I need to get better at trusting my body. But, yeah, fuck it. A little hour. It's not good, but I need to spend more time than I thought doing this other thing. So, got the goal. Bye-bye.